Section 8.1 Non-right triangles, law of sines. In this section, you will use the law of sines to solve non-right triangles. Find the area of the non-right triangle using the sine function, and solve applied problems using the law of sines. We'll now be learning how to solve problems that involve non-right triangles, or we call it oblique triangles. Here's the law of sines. In any triangle with the sides A, B, and C and respective opposites angles A, B, and C, sine A over A is equal to sine B over B, or sine B over B is equal to sine C over C, or sine A over A is equal to sine C over C. So any of those work out of any of those three. So there are two cases. However, the first one side and two angles known, and it has one unique solution: angle side angle or side angle angle, ASA or SAA, and two sides and one angle known, SSA. We call it ambiguous case. It could be one solution, two solutions, or no solution. Alright, let's start with example number 1. Solve the triangle shown below, SAA side angle angle to the nearest tenth. If this is side C, so then this is angle C. This is side B, so this is angle B, so definitely this is angle A, and side A is equal to 10. So this is side angle angle, so this is the S part, side 10, and this is angle angle. And also we know that the sum of all the angles of a triangle is equal to 180 degrees. So it should be A plus B plus C is equal to 180. So we have A and C. So A is 50 plus B plus 3 is equal to 180. You'll be able to solve for B. 50 plus 3 is 80. And if we subtract 80 is equal to 100 degrees. So B is equal to 100 degrees. Then to solve for the other sides, so we use the law of sines. So let's start with this. That is sine A over A is equal to, we can solve for, if you want to use this, sine C over side C. So that is sine of angle A is 50 over side A is 10, and sine of 30 degrees over side C. So we cross multiply, and to solve for C. So C is equal to, you can multiply this, 10 sine 30 degrees over, if we cross multiply this and divide both sides by, sine 50 degrees. Which is equal to 6.53. For B, so let's say you want to use this, sine of 100 over B is equal to, let's use sine A, sine of 50 over side A, which is equal to 10. So again, we use here sine B over B is equal to sine A over A. And then we cross multiply like what we did, how we solve for C. So B is equal to 10. We can multiply these two. So 10 sine of 100 over sine 50. And we'll be able to get B is equal to 12.086. So here are the sides and the angles of the given triangle. The angles A 50 degrees, B 100 degrees, C is 30 degrees, side A is 10, side B is 12.86, and side C is equal to 6.53. Okay, now let's try example number 2. Given the triangle here, solve the triangle shown below, side angle SSA to the nearest 10th. Side angle. So this is the side part, and the angle. So this is side angle. So if we have this as side A, so this is going to be angle A. So let's say this is angle B. So this is side B. And this is angle C. So this is side C, which is equal to 12. So let's start with solving for maybe angle B. So we can use this. That is sine C over C is equal to sine B over B. Sine of angle C is 85 degrees over side C given is 12 is equal to side angle B is equal over side B is equal to 9. And we cross multiply. So multiply this. So 9 sine of 85 degrees over 12 is equal to sine B. And to isolate angle B, all we have to do is angle sine, inverse sine both sides. So it's going to be inverse sine of 9 sine 85 degrees over 12 is equal to B. And if we solve this, B is equal to 48.34 degrees. Okay. Then next one. So we have now this angle B is 48.34 degrees. Let's solve for what's next? Solve for angle A. So we know that A plus B plus C is equal to 180 degrees. So A plus B is 48.34 plus C is 85 degrees is equal to 180. So A is equal to 80 minus 48.34 and 85. So angle A is 46.66 degrees. So now we can solve for side A. So we can use these two, that is sine A over A is equal to, so let's say use C, sine C over C. So sine A, sine of 46.66 over side A is equal to sine 85 degrees over 12. And to isolate A, you can multiply this. So 12 sine of 46.66 degrees over sine of 85 degrees. And use your calculator, you should be able to get A is equal to 8.76. These are the answers. The angles are A is equal to 46.66 degrees, B 48.34 degrees, C is equal to 85 degrees, and the sides A equals 8.76, B is equal to 9, and C is equal to 12. In this case, example number 2, it says one solution, meaning if we subtract our angle B from 180, we find that there may be a second possible solution. So that's why 180 minus 48.34 is equal to approximately equal to 131.66 degrees. And to check the solution, subtract both angles, 131.66 and 85 from 180. And let's do that. So 180 minus 85 minus 131.66, and we'll get approximately equal to negative 36.66, and which is impossible. It's a negative, so that's why your angle B, there's only one solution, which is 48.34. Okay, now let's try the next example with two solutions. Solve the triangle shown below SSA to the nearest 10th side angle. So this is side angle. So side and the angle part. Let's say these are the angles A, B, and C, and the opposites are the sides. So if this is angle A, so this is side A, which is 6. This is side B, and this is side C. So let's use love signs. Let's start with A. So sine angle A over side A is equal to sine of angle B over side B. We're going to use love signs to solve for angle B. So cross multiply. So that's going to be B, which is 8, sine angle A 35 over side A is equal to 6 is equal to sine of angle B. And to isolate angle B, so again we get inverse sine of the left side. 8 sine of 35 over 6 is equal to B. And using your calculator, B is equal to 49.9 degrees. So B here is 49.9 degrees. Check if there is one solution or two solutions. So after we solve for B, just like what we did for example number 2, so 180 minus 49.9 is equal to 130.1, and then we try to subtract from 180 35 and 0.9 130.1, and this is equal to 14.9, which is a positive, so that's why there are two solutions. And let's start with the first one. So let's use this first 14.9 as your angle C. So that is sine C over C is equal to sine A over A. So sine, let's use first 14.9 over side C is equal to sine 35 over side A is 6, and then we isolate side C, so we cross multiply this. That is 6 sine 14.9 over sine 35, and we'll get C is equal to 2.69. Okay, that's the first one. The second one is using the same, sine C over C is equal to sine A over A, but this time instead of 14.9 we use 95.1. So look at this, 180 minus 35 minus 49.9 is equal to 95.1. So this is the second triangle with 95.1 angle. So sine of 95.1 over side C is equal to sine 35 over side A is equal to 6, and then we can isolate C. So that is 6 sine of 95.1 over sine of 35, so that C is equal to 10.42. So that is side C here, and this 2.69 is here. Okay, so that is example number 3. Next, example number 4, this time with no solution. Find all possible triangles with the side length of 4 opposite an angle of 50 degrees and the second side length 10. So this is our triangle with the angles A, B, and C. Let's use the first one, angle 50 degrees and opposite is side length 4, which is your A, side A, and the second side has length of 10, so let's use that with a B is equal to 10. So let's use love signs. So sine of A over A is equal to sine of angle B over side B. So sine of 50 degrees over 4 is equal to side of angle B over side B, which is equal to 10. And let's cross multiply this. So 10 sine of angle P, sine 50 degrees over 4 is equal to sine of angle P. And then inverse sine both sides. Is equal to angle B. And this is 10 times sine 50 degrees over 4 is 1.915 is equal to angle B. And if you use your calculator, there is actually no solution. You'll see an error. Okay. Next. Area of non-right triangle. The formula for area of a right triangle is equal to A is equal to 1/2 base times the height. But that always assumes that the height makes a right angle with the base, right? So if we have an oblique triangle with sides A, B, and included angle C, we can use this formula. Area is equal to 1/2 of AB sine of angle C. So here C has to be the angle in between sides A and B. Okay, so take note of that. And let's work on example number 5. Rochelle's house is on a corner lot. Find the area of her front yard if the edges measure 40 feet and 56 feet with an included angle of 135 degrees. So let's say this is side A and this is side B. And remember, angle C has to be an angle in between the two sides. So this is going to be our angle C. So let's use the area formula. So area A is equal to 1/2. A is 56 times 40 times sine of angle C, which is 135 degrees. 1/2 of 40, that's easier, is 20 times 56 times sine of 135 degrees. And use your calculator, you should be able to get 791.96 square feet. Okay, next, this time, let's work on some application problems. We can use the law of sines to help solve problems that involve oblique triangles. Example number 6. Two radar stations are 20 miles apart and each detect an aircraft between them. The first station measures an angle of elevation of 35 degrees and the second measures 15 degrees. What is the altitude of the aircraft? So it says here that two radar stations are 20 miles apart. So let's say these are the two stations, A and B. This is 20 miles apart. And the angle of elevation of the first one is 35 degrees. And the second measure is 15 degrees. So this is, say, angle C, and then we will be able to solve angle C. That is, we know that A plus B plus C is equal to 180. So angle C is 180 minus 35 minus 15. So C is equal to 130 degrees. So this is 130 degrees. So you can use law of sines to solve for side A. So we're going to use sine of angle A over side A is equal to, we have now angle C, so sine C over side C. So that is sine of 35 degrees over side A is equal to sine of 130 degrees over 20. And we isolate A, so that A is equal to 20 of sine 35 over sine 130. So that A is equal to 14.98 miles. So this is 14.98 miles. Now, what we really want is to find the altitude. So this is the altitude, which is the height. So how do we get that? So we can use SOHCAHTOA. So remember, sine theta is equal to opposite over hypotenuse. This is the opposite side. So let's say we're going to use a sine of 15 degrees is equal to the opposite side, which is the height, over the hypotenuse, which is side A, 14.98. Then cross multiply to solve for h, the height. So 14.98 times sine of 15 degrees, and you will get h is equal to 3.88 miles. Okay. Next, example number 7. I estimated the height of the Coit Tower in San Francisco. Last weekend, I stood on the street and measured the angle of elevation to the top of the tower to be 39 degrees. I then moved 83 feet closer to the tower and measured the angle of elevation to be 50 degrees. Now the question is, how tall did I estimate the Coit Tower to be? Sorry. So let's say this is the tower. And I stood on the street and measured the angle of elevation to the top of the tower to be 39 degrees. So let's say this is 39 degrees. I then moved 83 feet closer to the tower. So let's see, from here to here, 83 feet closer to the tower, and measured the angle of elevation to be 50 degrees. We know that if this is 50 degrees, then definitely this is 130 degrees, straight line. And if this is 130, you'll be able to get this angle here. So 180 minus 130 minus 139 minus 39, sorry, is equal to 11 degrees. So this is 11 degrees. And with this triangle, using the red, we'll be able to solve for this side. So let's say side C, using law of sines. So sine of 39 over side C is equal to sine of 11 over the opposite is 83 feet. So C is equal to 83 sine of 39 degrees over sine of 11 degrees, so that we will have C is equal to 273.75 feet. So this is 273.75 feet. So let's say now we want to solve for the height of the tower. So let's say this is, I'm going to use a different triangle here. So I'm just going to copy this triangle here. So this is 273.75 feet, and we know this is a right triangle, and this angle is 50 degrees. We want to solve for this height of the tower. So again, SOHCAHTOA, so we can use sine of 50 degrees is equal to opposite over the hypotenuse. The opposite side is the height, and the hypotenuse is 273.75 feet. So that 273.75 times sine of 50 degrees is equal to the height, and here's your calculator. Height is going to be equal to 209.7 feet. Okay. All right. Next, let's work on some lecture questions. Number 1, the roof of the house is at a 20-degree angle. An 8 feet solar panel is to be mounted on the roof and should be angled 38 degrees relative to the horizontal for optimal results. How long does the vertical support need to be? All right, let's start with this triangle here. Oops. It's a right triangle. So if this is 38 degrees, this is 90. So we will be able to solve for this angle. So that is 180 minus 90 minus 38 is equal to 52 degrees. So this is 52. Then we want this support here. How long does the vertical support need to be? So this is the height. So we want to use this triangle here, this blue triangle here. I'm gonna sketch that here. So we know that this is 52 degrees, and this is what we want to solve for this height. And we will be able to get this angle since we have here 20 degrees angle here, and this is 38. So now this is going to be 18 degrees. So if this is 52 and this is 18, so 180 minus 52 minus 18 is equal to 110 degrees, which is this angle. So this is 110. So now we can solve for the height using the law of sines. So sine 18 degrees over the height is equal to sine of 110 degrees, because we know that given this is 8 feet over 8. then isolate the height h. So 8 sine of 18 degrees over sine of 110 degrees, so that h is equal to 2.63 feet. Okay, and the last one, example number 2, find the measure of angle x if possible and round to the nearest tenth. So let's use law of sines. So this sine x over side 13 is equal to, let's use this, sine of 22 degrees over side length 5. Then we want to isolate x. So if we cross multiply, sine x is equal to 13 sine 22 degrees of 5, and then inverse sine both sides, solve for x. And use your calculator, x is going to be equal to 76.9 degrees. Okay, and that's it for section 8.1. And if you have any questions, let me know. Thank you.